So previously we studied about the different types of irrigating solutions or irrigating methods available. So now in the next topic or today's topic we will see about the different types of irrigating techniques which are used to achieve maximum effect of the irrigating solution. So there are few parameters that will evaluate the efficacy of an irrigant. First one is the volume, then concentration of an irrigant, then surface tension of the irrigant, then canal anatomy. Working time is how much time the irrigant is staying inside the root canal or coming in contact with the tissue, then temperature of the solution and depth of penetration and what type of method of delivery is used to use the irrigant. So this is a flow chart will tell us about what are the different types of techniques, irrigation or agitation techniques which are available depending on the manual and then machine assisted. Manual includes syringe irrigation, brushes, then manual dynamic agitation of the irrigating solution. Then machine assisted includes rotary brushes, continuous irrigation, technique using rotary instrumentation, sonic, then ultrasonic method which includes continuous and intermittent, then pressure alteration devices. Then coming on to the topic, the needle and the syringe. And the syringe and the needle allows the exact placement and replenishment of the exiting fluid, rinsing out the larger debris of the particles as well as allowing direct contact of the ingredient to the microbial so in passive type of irrigation, the actual action of the irrigant is restricted to 1 to 1.5 mm apical to the needle, with the fluid dynamics taking place near the needle. Then volume and the speed of the fluid flow are proportional to the cleaning efficacy inside the root canal. Diameter and position of the needle outlet will determine the successful chemical-mechanical debridement. Placement close to the working length is required to guarantee the fluid exchange in the apical portion of the root canal, but also control is required to avoid extrusion of the irrigating solution. Then excess pressure or binding of the needle should be avoided in the canal during irrigation with no possibility of backflow of the irrigant should be avoided under all circumstances to prevent extrusion of the irrigant in the periapical spaces. In immature teeth with wide open or wide apical foramina or when the apical constriction no longer exists, special care must be taken to prevent irrigation from extruding into the apical area and potential accidents happening during the procedure. There are different sizes and types of irrigation needle available. The size of the irrigation needle should be chosen depending on the canal size and the taper of the canal. So gauge of the needle. Gauge means the diameter of the needle plays an important role depending on the size of the root canal. Gauges ranging from standard 22 gauge to final 30 gauge needles are very ineffective for aeronautic irrigation. Since the irrigation in the apical third requires needle to be in close proximity, Abu Ross and Ram and Pinocchio at the stated that the canal's content should be flushed with 27 to 30 gauge needle placed in the apical third. However, Semia, Marshall, and Rosen pointed out that the in fine needle sodium hypochlorite would be deposited as crystals. So this would obstruct the needle and require more force for irrigation of the sodium hypochlorite. So they stated rather than using a finer needle, better to use a large needle and allow other methods of carrying the sodium hypochlorite in the apical method. The needle should be bent at an obtuse angle to allow easier access and entry into the orifice. So this bend is placed closer to the hub of the syringe to allow any breaking of the needle during the procedure. The designs of the needle, various designs of the needle are available in the market, open-ended blunt needles, specifically which are used for aeronautic irrigation. First one is open-ended blunt needles, then bevel needles, blunt-ended side bending needle, which is known as pro rings, notched tip, which is known as monojet, which allows a block backflow and doesn't create any pressure in the apical region. Then perforated needles, which is known as endo-wedge, introduced by Goldman and others. So this is a diagrammatic depiction of the needles, which are stated blunt end, then beveled, then side venting, then perforated needle. So these are the different types of diagrammatic depiction. The effective canal clearance with the chlorine system is attributed to its tip design with the lumen being 2 mm from the tip. This creates a turbulence along and beyond the probe. This also prevents forceful injection of the irrigant in the periapical region. But disadvantage of this needle is too much force is required to use the allow the force the solution through the needle. Goldman and other advocated clearer canals with the perforated needle system, which are introduced by them in 1976. However, Mosser and Henner revealed that these needles fractured even if slight bend was applied because they were perforated. And sturdity of these needles was not confirmed. Recent innovation includes Stopco irrigation system, which includes delivery and recovery of the irrigant in one probe. The needle delivers the solution and aspirates the solution held in the same. The aspirator is also connected with the same sheet that retrieves the delivered irrigating solution. So, reducing the chances of irrigant going beyond the apex. So, as a technique for this drip irrigation includes isolation using rubber dam, then fill the syringe via hub irrigant stored in the dampened dish by chairside. Somers technique will place a few drops of irrigant into the chamber, then whirlpool the solution into the canal with a small file. Grossman techniques advocates flooding the pulp chamber with the irrigant, and once it is placed in the canal, this serves as a reservoir of irrigant to replenish one present in the root canal as being instrumented. When the needle is introduced into the canal and milk syringe is drawn, few minutes be away to prevent it from wedging and forcing the irrigant from the periapical tissue. Once the irrigant delivery starts, look for the backflow of the irrigant from the canal orifice. The hand holding the irrigating solution is kept away from motion when dispensing the irrigant. Files potentially carry the irrigant into the deeper region by surface tension. In small canals, the files displace the irrigant. When the instrument is withdrawn, the irrigant slowly flows into the space which was previously occupied by the file. Clinician should irrigate copiously and recapitulate with the previous number file and re-irrigate after each instrument to prevent blocking of the root canal, which can be happen due to dentinal tubules or vegan solution not reaching the periapical region. Besides using the aspirator, Grossman suggested the use of a gauge sponge held against the tooth to observe the backflow of the irrigant. Once the shaping and cleaning is achieved, the irrigant is aspirated from the canal with the syringes and subsequently dried using paper quilts. Another system is endo-irrigator system, which delivers various kinds of irrigants from one office air pressured bottles at push of a button. Various gauged cannula can be selected and attached to the irrigating handpiece, which allows the clinician conveniently choose, dispense, and effectively irrigate the root canal system. Another technique is or the another irrigating method is contact irrigation method, which is also known as continuous irrigation during rotary instrumentation. A self-contained fluid delivery unit that is attached to a contact endo system. It uses a pump console to irrigation reservoirs and a tubing to provide a continuous irrigation during instrumentation itself. So during continuous irrigation, irrigant agitation during the active rotary instrumentation would generate increased volume of irrigant, increased irrigant contact. More effective canal debridement compared with the syringe needle irrigation is achieved, but no significant result is seen in the middle and the apical third of the root canal, according to Walter Ritter in Journal of Endodontics in 2002. Then coming on to another technique, that is manual agitation technique, involves the dispensing of an irrigant into the canal through needles or cannulae of variable gauges, either passively or with agitation by moving the needle up and down the canal space without binding it on the canal walls. The design of these needles can be closed-ended, side-vented channels. Good control of the needle depth and the volume of the irrigant can is flushed through the canal. However, closer the needle tip is positioned to the apical tissue, the greater chance of apical extrusion of the irrigant. This must be avoided if the sodium hypochlorite is used as an agent to where to extrude past the apex is a chance that is catastrophic extent that can occur during the treatment procedure. Then manual dynamic engineering involves gently moving a well-fitted gutta-percha master cone and down in short 2 to 3 mm strokes within the instrumented canal, thereby producing a aerodynamic effect and significantly irrigate exchange. Significantly more effective than automated dynamic irrigation system and static irrigation and provided better cleaning of the root canal. The next is a Maxi Pro, which is a modified design of a regular manual irrigation needle with a well-rounded closed tip and side port dispersal. The needle is available in a wide range of gauges, which ranges from 21 to 30 gauge. Durlock connector provides a secure attachment and easy removal from any disposable syringe. Rounded tip prevents the risk of perforating the apex and allows safer irrigation of the entire length of the root canal. Dispersal of irrigating solution through the side port of the cannula creates a unique upward turbulent motion, thoroughly irrigates the root canal preparation but prevents solution and debris from being expressed through the periapical foramen. This is a picture of Max probe showing the side venting of the or perforated side venting of the needle. Then coming on to the next one are the rotary brushes. A rotary handpiece attached with a micro brush has been used by Ruddle to facilitate the debris and smear layer removal from the instrumented root canal. The brush includes a shaft and a tapered brush section. The latter then has multiple bristles extending radially from the central wire core. During debridement phase, the microbrush rotates at around 300 rpm, causing bristles to deform into the irregularities of the preparation. This helps to displace residual debris along out the canal in a coronal direction. However, this product has not been used commercially since since the patency was approved in 2001. Coming on to sonic irrigation, it operates at a frequency of 1 to 6 kilohertz. Examples for this irrigation are Vibringe and Endoactivate. Vibringe allows a delivery and sonic activation of the irrigating solution in one step. It employs a two-piece syringe with a rechargeable battery. The irrigant is sonically activated as the needle attaches to the syringe. Endo activator is a system more recently introduced, consists of a portable handpiece and three types of disposable polymer tips of different sizes. The tips are claimed to be strong and flexible and do not break easily due to activation. They are smooth and do not cut the dentin. Effectively clean the debris from the lateral canals and remove the smear layers, also dislodges the debris. Produces a cloud of debris that can be absorbed within the fluid-filled pulp chamber. Vibrating the tip in combination with moving the tip in upward and downward direction in short vertical strokes synergetically produces a powerful hydrodynamic phenomenon. Only disadvantage are the polymer tips which are not radio opaque. Because of this non-radio opacity, they are difficult to check into the radiograph. If so, they are broken during the treatment. This is a photographic depiction showing an endoactivator and Y-bridge, which is specifically used as sonic irrigation system. Then coming on to ultrasonics. Ultrasonics has a very wide variety of usage in aeronautics. They are not only used during irrigation, but they are also used in various retreatment procedures. They are used to clean the root canal. So not only irrigation, so it has a wide variety of ranges. But today in this chapter, we are studying about their use for irrigation purpose. Richmond introduced the ultrasound in aeronautics as a means of canal debridement only in 1957. As at the U.S. Navy Dental Center, Martin and Cunningham developed a system which used ultrasonics for preparing the root canal. So the power source they employed was a magnetostrictive unit. Recently, a piezoelectric unit has been used. This technique was termed as synergistic system because the instrument abrades the dentin and delivers a copious flow of the irrigant to the along the tip of the instrument. The instrument takes mode 0.001 to 0.004 of each through a push and pull motion of the handpiece at a frequency of around 20,000 to 25,000 hertz. A continuous irrigant flow is provided along with the treatment of 45 ml of a solution for 1 minute. What are the effects of ultrasonic? First one is the heat generation. As the instrument is activated, frictional heat is generated with the warm, which warms the sodium hypochlorite element, in which in turn increases the tissue dissolving property and making it more bactericidal. Cameron found that the temperature peak of 45 degrees was recorded and external root surface temperature was 40 degrees when ultrasonic was used. The thickness of the root dentin had an effect on the rate of temperature change. They also found that because of the large diameter, large difference in acoustic density and shallow angle of the incidence, much of the incident wave was reflected and less than half of it passed through the irrigant dentin interface. The wave that did not pass into the dentin was reflected, scattered, and absorbed by the dentin and was converted to heat energy. Mechanism involved in the ultrasonics. First one is cavitation, next one is acoustic streaming. These are the two effects produced by uh, ultrasonics during irrigation procedure. When cavitation, when a vibrating object is immersed in the fluid, oscillations are set up in the liquid. During the rarefaction phase, the liquid can fail under stress and form bubbles, which is also known as pseudo cavitation by camera. During the next positive pressure phase, these vapors fill the cavities, collapse implosively, producing a high temperature and pressure of gas still contained in within the cavity. This high temperature and pressure in turn results in radical generation and radiate shock waves from the collapse of this leads to water hammer action on the solid surface. Acoustic streaming is a rapid movement of the particles of fluid in a vortex-like motion about a vibrating object, but also has associated with small gas bubble production, which are set along in the oscillation by the fluctuating pressure field generated by the file. Ahmad et al. Found that a streaming pattern where liquid was transported from the apical end to the coronal end of the file in a region very close to the file. An irregular array of rapid eddying motions were observed concentrated at the apical end of the file. This would be more capable of dislodging debris and microorganisms along the root canal. So these are the picture where you can see cavitation along the tip of the instrument, the production of cavitation and acoustic streaming along the length of the file. Two types of ultrasonic instrument units are available. First one, ultrasonic instrumentation and irrigation, that is UI. Then passive ultrasonic irrigation, that is PUI. UI consists of constant of vibratory motion and cleaning efficacy of an ultrasonic fine with the non-flared root canal space. UI leads to strip perforation and irregular flaring of the root canal. So passive ultrasonic irrigation came into light, which allows the energy to be transmitted from an oscillating file or a smooth wire to the irrigant into the root canal by means of ultrasonic waves. Activation of rinsing agent without simultaneous preparation of the root canal is achieved through passive ultrasonic irrigation method. It promotes the tissue removal and dissolution of the debris. Disadvantage of these are very often an instrument comes in contact with the wall of the root canal, it oscillates. The oscillations are dampened, so thereby rendering them ineffective. So if the ultrasonics need to be effective, the instrument need to be not in contact into the root canal. Ultrasonics and micropressures advances in small wire technology, injection molding processes, bristle materials, and bristle attaching techniques have led to the creation of an endodontic microbrush. The bristles can be attached to either braided wires or flexible plastic cores. Fabricated as either rotary or ultrasonic endobrushes, they contain 16 mm of bristles with a DO of D0 bristles diameter of 0.04 0.05, 0.6 or zero point 0.8 mm. They have non-standard Gatapacha mastercone tapers, fine, medium and large, used in conjugation with sodium hypochlorite and EDTA to produce cleaner canals. Coming on to the next is endobat, which is combines irrigation and evacuation system combined in a single system. This includes a negative pressure irrigation system which utilizes the negative pressure at the apical termination. Irrigation solution are sucked away from the apical foramen, virtually eliminating the risk of irrigant accident. In a negative pressure irrigation, irrigant is delivered into the access chamber and a very fine needle is connected to a suction device then transported apically and ultimately removed via suction. Endovac system includes a micro cannula size ranging from 55.2 taper and plastic in material, and a micro cannula which includes a stainless steel needle on size gauge of 32 and evacuation tip. First step in this method is a master delivery tip is used to overcome several clinical problems. First, it avoids excess sodium hypochlorite from spilling into the patient's mouth regardless of the arch. Secondly, it provides a frequent and abundant flow of irrigant while maintaining the desired effect of a constant drink full level of the irrigant. Position the master delivery tip at the metal cannula with the master delivery tip is placed just inside the access opening of the tooth. It delivers irrigant via syringe and excess fluid will be constantly evacuated simultaneously along the delivery of the irrigant. The master delivery tip is used to during a coronal flaring and each after each instrument change to remove the gross debris of the during instrumentation. Then second step is a coarse debris evacuation with a macro cannula. All the instruments are, when instrumentation is complete, use a macro cannula with a titanium handpiece to remove the coarse debris, while master delivery tip to ensure the abundant supply of irrigant. In this step, the macro cannula and the micro delivery tip are used at the same time. It is helpful to have a dental assistant during delivering to deliver the irrigant with the micro delivery tip, while the clinician works with the macro cannula up and down the canal within the few millimeters of the apical termination. Then third one is a microcannula microscopic debris evacuation. Finally, the microcannula on the small titanium finger piece. The microcannula is placed along the working length of the root canal. The micro delivery tip delivers a sufficient irrigant as the microcannula draws the solution the full along the length of the root canal, evacuating microscopic debris less than 100 micrometer size. This was about endovac system. Then coming on to rinse endo system. It is based on pressure suction technology. 65 ml of rinsing solution oscillating at 1.6 Hz is drawn from the attached syringe and transported to the root canal via an adapted cannula. During the suction phase, the used solution and the air um, air are extracted from the root canal and automatically merged with the fresh rinsing solution. The pressure sucked cycles change approximately 100 times per minute at a frequency. Apical third of the canal might be effectively rinsed with the cannula restricted to the coronal third of the root canal because of pulsating nature of the fluid flow. However, higher risk of extrusion in the apical region is observed with this method. This is an example of a ring window system. Coming on to the next is the photo activation disinfection method or photodynamic therapy or light activated therapy, which utilizes a selectively accumulated or endogenously produced photosensitizer, activation of which by a specific wavelength produces a deleterious chemical entities that kill the bacteria. A strong oxidizer generated during the process can act on multiple targets in a microbial cell, resulting in the membrane damage, enzyme activation, and DNA damage, etc. It has a wide spectrum of antibacterial activity with a minimal chance of giving rise to a resistance to microbial population, making it an ideal disinfecting method. Principal agent in killing bacteria is oxygen-based free radical. This instrument includes a small diode laser which is connected to a delivery fiber, which is a disposable handpiece. The emitter consists of a flexible hollow tube coated internally with a light diffusing material of a comparable size of tip, which is compatible with the ISO standard number 45. The light is emitted over a 15 millimeter length of the tip with a uniform energy density. This energy density increases over 30% at the tip. This is used in conjugation with 12.7 grams per liter solution of photosensitizer, that is the toluene chloride, which is pharmaceutical grade vital stain toluene blue 0. So procedure, how do you use this method, this instrument? After completion of the canal preparation the canal is inoculated with the photosensitizer solution, which is left in situ for a fixed time of 60 seconds to permit the solution to come in contact with the bacteria and diffuse through any biofilm structure. The emitter is then placed into the root canal and irradiation is carried for 120 seconds. The principle behind this is a photosensitizer molecule attached to the membrane of the bacteria. Irradiation light that at specific wavelength matches the peak absorption of the photosensitizer leads to the production of singlet oxygen, which causes the bacterial cell wall to rupture and leads to the killing of the bacteria. Advantages of this are it overcomes the problem of antibiotic resistance. It does not pose any thermal risk to the low power of the pad laser. Can be applied effectively for killing gram-positive, gram-negative, aerobic and anaerobic bacteria. This method kills the bacteria in a complex biofilm such as subgingival plaque, which are typically resistant to the action of any antimicrobial agent. So this was about the various root canal irrigating methods. So debridement of the root canal is essential for a predictable, successful aeronautic treatment. Instrumentation of the root canal must be supported by the irrigation system for the best results. Irrigants in aeronautic therapy are must and are many. So it is for the clinician to select the particular irrigant depending on the observations, sterility, canal configuration, and other considerations which might affect the success of the root canal system.